This is the Advanced Data Mining CA1 for Team C, who are Stephen, Danny, Anna and Louise. We are using a data set from Kaggle, which contains prudential information, and this data holds a response variable from a series of different variables which has a value of 1 to 8. The objective of this project would be to try and use clustering to map to these response variables a number of different clusters, and then try and predict how these response variables are defined. The dataset contains personal information, product information, employment, insurance and family information. And the data also contains 13 columns of incomplete data. Of these 13 columns, 4 columns has less than 30% populated, so we've removed those, and the remaining 9 we've populated by means values, which we'll explain in our script. So here we can load the training into our data set. And from here we can impute the 9 variables that we need to, as well as removing the remaining 9. So we run those down through those. Okay. So now we can look at the techniques that we've applied to this data set. Okay. So the first was to try and correlate the data in the data sets to see was there any correlation, and if there was, to try and remove this. So when we run this, this gives us a list of correlations, which I've since removed and into Excel, which we can view these here. And I have changed the color of the values that are between 8 and 0.8 and 1. And we see that there are very few variables in the data set which correlate, so we don't really have much of an opportunity to reduce our data set size. So returning back to the OR script, we are using primcomp here to do the PCA. So if we run this through, and we have a look at the summary. This explains the standard deviation and population of variance of all our columns. And from this we can plot this onto a graph. We can see here that there isn't really a drop off from the first cluster to the second. It seems to be quite a curve. So the eigenvalues here in this data set don't really have an elbow at which we can cut off remaining clusters. We can also plot the same information this way. Okay, and we can see here our data values. If we zoom in on this, we can see here that there are fields all listed and the distance between them, but they all seem to merge in a bit of a blurb here. So this diagram doesn't really give us any indication as to the structure of the clusters or the distance between the related fields. So we'll try and plot this information in a different way. We also applied the PR comp also as well, to a different approach, but this doesn't perform well either. To get a 3D plot of the information, we can open this up, and this gives us quite a good view. We can see from this view the clusters that are defined, and you can see here that there does seem to be a split in them when we use this 3D graph, which gives us an interesting perspective on the data, but again it doesn't really tell us much as to how the the clusters are differentiated from each other. So if we try to put this into a 3D text plot, and let's have a look at this. So again, here a different graph which is similar to the previous one, but again it outlines the distances between the variables in the clusters, but doesn't really give us the clusters aren't separated on this 2D diagram. So let's go back to our script again and try some more unsupervised clustering approaches. Okay, so our k-means here, click on this, and we can apply a 3D plot on the k-means results. And we can also change this to be a plot on a field by field basis to see if we cluster at a field level, does that give us any clearer picture on the data. So you can see here we've got another similar 3D plot, and again we can see how the two clusters have been separated, but again doesn't give us any real indication as to which fields make up the values in these clusters, because I suppose the data set itself holds so many fields that it's hard to reflect this in a cluster diagram like this. So we can also look at the data in a hierarchical structure, and to do this we've looked at implementing dendro diagrams, and because of the large data set we've tried to restrict the amount of information on this, so we've used a sample of the full set. And if we have a look at the tree diagram for okay, well let's try a different one there. Complete. So we can see here how we have how different approaches to measuring distances between the points in the cluster can lead us to different cluster diagrams and these dendro diagrams. And if we try another one here called equity, I'll try and plot this one. So I guess this just points out the importance of using the appropriate measuring settings when defining your clusters, and you can see how they can differ broadly depending on which one you use. We also employed an alternative PCA approach to this using Barunta, but this too failed to establish any correlations in the data. So I suppose if we come back to our slides, the previous objective was to try and link the response variables to certain clusters, and you can see from our results here that the response variables didn't really map very well to the clusters we defined. So that leads us to believe that maybe clustering isn't the best approach to review and summarize this data. Thank you.